In today's world, nearly everyone wants to quote a study to prove their point. And this is very confusing because it's research, right? If it's been studied, then it has to be true. But 2 seconds after that, someone brings up a study for the opposite view. Dead opposite, literally. So now who do you believe? That's what we're going to solve in today's episode. We're going to be talking all about research, how it works, and how maybe not all studies are created equal.
Welcome to the Practical Pet Parenting Podcast, where science and research meets simplicity, practicality, and humor. Because we all know that pet parenting isn't just one thing. It's magical, beautiful, life-changing, frustrating, and overwhelming all at the same time. I'm Dr. Ashita Suresh, a vet, a mom, a dog mom, on the multiple species pet parenting journey just like so many of you. Join me as we cut through the noise, fear, and fluff and take pet parenting from overwhelming to, well, barely manageable.
So, to learn to evaluate research, we'll have to understand how it works and how it's conducted. So, let's take a simple example. Now, to start with, I need a statement that I want to prove. Let's take something like plants need water to survive. Now, I want to prove that they need water to survive. So, to prove this, I will take two plants, give one water, not give the other one water. And if the plant without water dies, it's been proven, right? Not exactly. So, first thing I would need to make sure is that I put the plants in the exact same conditions, meaning they both need to get the same amounts of sun, have the same soil, and all of these. I can't put one in the light and one in the dark. The only difference needs to be watering. Everything else should be the same. If there are other differences, we don't really know if the plant dies because of not watering it or because of those other differences. That doubt will be there. The second thing is I need the same type of plants. I need to test the same type of plant. If I don't, the results won't be reliable. If I compare a cactus to a marigold and I don't water the cactus, it may easily come to the conclusion that plants do need water. By now, I feel like you're getting the feeling of how easy it is to make a misstep and come to the wrong conclusion. The third point is how long did I continue the study? If I had done it like only for a day or two, I watered one plant and I didn't water another plant for like 2 days, I could easily say that plants can survive without water because there was no noticeable difference. It does take a certain amount of time to show results, and it is very important that the study is continued for that amount of time. Fourth, how many plants did I test on? If I tested it on only one or two plants, there are more chances that it could be luck. That one of them might have been a cactus and I didn't know it's a cactus. It didn't look like a cactus. But if I do it on multiple types of plants, multiple times, then yes, there's more of a chance that it is the truth. It is an actual finding. It is definitely a thing. And the fifth and probably most unpredictable element is dumb luck. Yes, it's a very important factor in any research, and a lot of effort and a lot of calculations is made and done to make sure that it does not exist as a factor. Some of the things that have been done are two fancy words called significance and power of a particular study. Now, significance just means that the likelihood of the result being due to chance. It's also known as the p value. It's something that you can check in almost any research paper, and the lesser that p value is, the more likely it is that it was a very tightly controlled study and it is not due to chance. Generally, in most data, we need the p value to be below 0.05. They're just trying to say that there's less than a 5% chance that it could have been due to luck, and that is great. This is also a hallmark of the quality of good research, that they do not accept anything more maximum more than 5% of chance of it being a mistake or luck. The next one is power. Now, power is the likelihood of detecting a result if it exists. In simple words, this is the chances of us getting our facts right. The higher the power, the better. Studies with larger sample sizes often almost always have higher power because there are so many test subjects there that a significant result is extremely hard to miss. Alright, I've done a study, I have some results, and I want to tell people about it. So, what do? I publish it. I send it to a scientific journal which basically checks for all the things that I just talked about, and a committee of experts in the field decide whether it is worth publishing or not. Now, like anything else, some journals publish only the highest quality papers, and others would overlook a lot of things for a fee. Not all journals are created equal. Okay, now I have gone on and put out research that plants need water to live, and it's in a good journal. Now, scientists are by nature competitive, so a lot of really smart people, maybe all over the world, will look over what I did and they get fascinated about it. And they perform their own versions of the same experiment with some minor tweaks, maybe some different durations, maybe some different plants, maybe different weather conditions. They do all these things, they publish their own studies, and that is how we slowly have a mountain of knowledge being built on a particular topic. It starts with one and it snowballs. It may take years, months, depending on the topic, but that is how we slowly build knowledge one on top of the other. There will be some hits, there will be some misses, but we keep studying, we keep trying, and we keep understanding. After all this, now it's not over. When the body of information is built, some very smart, very experienced person, probably a person who is in this field for many years, they're probably their entire career, will go and put all these research papers together and write something which they call a review of literature. What they do is they take up all the papers, put it all together, they write, and they give their opinion on all the results together. Now, this is only done by someone who is an expert in the field, and it's only valid if an expert does it and not a beginner. So, is that it? Can we go a level higher than that? Turns out we can. Now, some very smart people take every single study there is, for example, on plants and water. They take all the numbers, all the data published from all the papers, and get a very smart computer or AI to crunch them and see if there is a consistent result. This is known as a meta analysis, and right now it is the most accurate form of data you can find. For now, I mean, we don't know what's going to come up later. I don't know about you, I'm already exhausted and fascinated at the same time by now. So, now that we've discussed all this, the next time someone says there is research or a study said, what should you do? First of all, ask them to give you their source. And no, don't accept ChatGPT or Claude links or any AI link. Ask for a link to the direct paper. Next, look at the sample size. If it's been tested on maybe like 5 or 8 or 10 people, chances are that it's a very preliminary study and more research is needed to be done and it cannot be applied to the entire population as of now. Next, look at the conditions of the study. For example, if the study is looking at the effectiveness of raw food, then check the other things. Were the dogs at home or were they in a controlled environment? Like, was the only difference being raw food? If they were at home, then two dogs' lifestyles can be entirely different. You cannot say that it was only because of the food. Next, check the data. Now, you don't have to be an expert in numbers or anything like that. You can just easily just check the parameters. Simply being, were they objective? Like, were they blood reports or something that has a proper number, or were they subjective things like opinions, like survey for the pet parents? Like, do you think your dog did better? We may be biased, we may be mistaken, or we may straight up lie. So that data does not hold much value as objective things like, blood reports or blood values, things like that. Next, like I said, check where it's been published. Check things like impact factor and citation analysis. You can ask AI for these to know more about where the particular journal that it's been published in stands in the spectrum. Lastly, check whether it is actually research or an expert opinion. Why an expert opinion is valuable? It's actually the least accurate form of data because ultimately it's still coming from a person whose experience may have been influenced by a lot of things. They may have worked in a place where a certain disease is very high. That does not mean it is very high in the entire population. Things like that. And always look for reviews or meta analysis which have the best quality research. So, again, check where the data is coming from. I know this was a lot, but in today's world, we do need to be prepared because there are too many people willing to twist and cherry pick research data to suit their own purposes, and we need to know how to think critically. Please do feel free to rewind and listen to any part of this episode that was confusing to you. While there's a lot of data out there, remember that not all of it needs to be legit. You may have to be an expert to conduct quality research, but you don't need to be one to spot nonsense coming from a mile away.
Thank you so much for listening to the Practical Pet Parenting Podcast. If you found this helpful, don't forget to follow, rate, or review. Whatever your podcasting app allows you to do it. You can also find me on Instagram at Indian Pet Vet and read more at practicalpetparenting.com. Much love to you and your pets, and see you next week.